Okay, so we can click finish, done. All right, so we have completed the initial nodal analysis, and now we will go to stimulation to design the math asset. Go to stimulation, this one, math asset stimulation of sandstones. Okay, so you need to understand about math asset simulation, math asset stimulation before doing this design or simulation in Prosper. So I assume you already understand that. So we will skip the basic and we will do only the demonstration. Math acid is actually the combination of hydrofluoric acid, HF, and hydrochloric acid, HCl. This acidizing is done especially in sandstone formation. All right, so here we have the wizard, math acid stimulation of sandstones. Input data, we have options, reservoir parameters, well parameters, latest well test data, rock properties, formation composition. And after we perform the calculation by pressing this calculate button, the results, we will get calculated rock properties, the recommended treatment results, pumping schedule, and damage removal. All right, interesting. So you can follow me for the input data, damage type. All right, for damage type, we will select this one, no damage zone exists. The math asset treatment serves to remove minerals in the matrix. You can open the drop down and you can see some scenarios. But in this case, we select this one, no damage zone exists. We just want to remove minerals in the matrix and hope that we can get higher PI, higher productivity index. All right, calculation type, open the drop down, calculate optimum formulation based on ionic equilibrium. Interesting. And volume of acid available, let's say 10,000 in gallon. All right. And for the reservoir parameters, overburden gradient, you can follow me or you can follow the default number. And the drainage area, for example, 500 acres. All right, drainage area of our well. And for the next section is the well parameters, borehole diameter, 8.496 inches, perforated interval, 100 feet, shot density, 8 per foot, perforation tunnel diameter, 0.62 inches. All right. So you see, we actually need all these parameters before performing acidizing design. And okay, let's say latest well test data. You can follow me, 10,627.8 with 0 water cut. And let's say permeability from well test, we get 50 millidarcies. All right, and now we go to rock properties, porosity 0.2 in fraction with rock bolt density 166 pound per cubic foot and rock tensile strength of 500 psi and Poisson ratio 0.2 in fraction. All right, and for the formation composition, you can see it is in percentage of weight. So you can follow me. Let's say the composition of our rock, 67 quartz, no kaolinite, no illite, no montmorillonite. We have mica and mixed clays, no albite, no microcline. We have mixed feldspars. We have calcite, 18%, and no dolomite. All right, so far so good. So we have completed the input data. Let's see if we press calculate. Warning. Yeah, you can read the warning. Use of HCl spearhead is vital to prevent precipitation of calcium fluoride or CaF2. Okay, so usually for matte acidizing, we use HCl for pre-flush to prevent this one, precipitation of calcium fluoride. All right. Okay, so we can click done. The calculation has finished very fast. And you see what we get. Very, very, very interesting. I will maximize the window. I get these results. I got the given bulk density. I know the calculated matrix density. Interesting. I know the aluminum in bulk rock, right? Calcium in bulk rock, and the treatment results. The concentration of HF, hydrofluoric acid, recommended is 5%, whereas the HCl percent is almost 19%. Porosity increase, we get this one, almost 25%. Porosity before treatment is 0.2. And after the treatment, we can increase the porosity to approximately 0.25 in fraction, 25%. All right. Permeability increase, 71%. So before the treatment, our original permeability is 50 based on well test. And after the treatment, we get the permeability increase to 85% or 85.7 millidarcies. And you can see the total dissolved minerals, this one, gram per liter. And this is the recommended pumping schedule. So we need to only perform it in one stage with maximum injection rate of 8 barrels per minute. All right, very interesting. And the maximum tubing head pressure, this one, to prevent also the fracturing. Fracture gradient, calculated pump requirement, the horsepower, recommended flushes per stage. All right, 2000 gas oil in gallon. With this one, the alcohol, the HCl pre-flush, matte acid, all right, the alcohol again, and gas oil. Damage removal. So the radius treated zone is 23.7 inches, the radius of the treated zone. Permeability damage zone, almost 50 millidarcies, right? And this is interesting. The PI before treatment is actually 5 as per input. And after the treatment, we can increase the permeability or the productivity index to 5.37 stock tank barrel per day per PSI. And skin factor after treatment, we can achieve negative skin factor of negative 0.7. All right, so you can see we get improvement, we get negative skin factor, we increase the productivity index. So we can take this number and we will input in nodal analysis section and we get the new nodal analysis, we get the new IPR. All right, so let's keep this number 5.38. Okay, so we click done. So we have completed the stimulation section, the matte acidizing section. Interesting. And now we need to go to calculation again.